Very good morning to one and all present here. Today in this video we are going to see how to implement a Boolean expression using a multiplexer. So here we can use, if suppose let us assume f equal to sum of m of 0, 5, 6, 8, 12, 14, 15. So this is the minterm functions given as a problem. We have to implement this function using multiplexer. For the first step means we have to identify what's the greatest value from the given minterms. So here 15 is the greatest value. So which means in order to represent the 15 we need the binary value 1 1 1, which means it requires 4 variables. Let us assume it's going to be A, B, C, D. So A, B, C, D, here A is the most significant bit and D is the least significant bit. So 4 variables can be used to implement these expressions. So what are the different kinds of max that can be used here means, so 2 power 4 which is going to give 16:1. So we can implement this one by using 16:1 max. Similarly, we can also use 2 power 3. So that is the maximum value is reduced by 1. So it is going to be 8:1 max. And similarly, we can also implement by using 2 square, that is 4:1 max. So here we are going to discuss to implement this any given Boolean function using 16:1 max, 8:1 max and 4:1 max. So what are the different steps that has to be followed? So that's the main objective of this video. First let us start with the 16:1 max. So for 16:1 max we record 16 input lines and 4 selector lines and 1 output. Here we have 4 variables. So that 4 variables can be assigned as a 4 selector lines and 16 inputs can be selected based on these values. What are the values present here is going to be given as logic 1. The values which doesn't appear in the given function is going to be logic 0. So which means we can going to introduce a 16:1 max. So 4 selector lines, they are going to be A, B, C, D. Similarly, we are having 16 inputs 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here we are going to take only 2 values, that is plus VCC and ground. The value present in the given functions are going to be connected with the plus VCC, that is 0, 5, 6, 8, 12, 14 and 15. They are going to be connected with this plus VCC. Similarly, the value doesn't present are connected with the ground. So this is the simplest one, but while considering the cost, 16:1 max is costlier. So in order to avoid the cost wise price, we are going for another max, that is 8:1 max. So in 8:1 max we have 8 input lines and 3 selector lines. So here we have 4 variables. So in the 4 variables we are going to select 3 variables as the selector lines. So normally we are going to select either B, C, D and A is going to as a data line. So if you consider B, C, D as selector line means B is going to be the MSB bit and D is going to be least significant bits and A is going to act as a my data lines. So in order to have the data value, we are going to separate A as 2 literals, A bar and A. So A bar is going to store the value of 0. So wherever that combination, that is we have A, B, C means we have 16 combinations. In the 16 combinations, A holds the value of 0 for 0 to 7 and A holds the value of 1 for 8 to 15. So we are going to assign A bar for 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. So, this 8 value is going to hold the value a equal to 0. Similarly, 8, 9, 10, 11, 12, 13, 14, 15. So, this 8 value is going to have the value a equal to 1. Now, what we are going to do means we have to take the problem. So, for the given min-term values, we are going to round this value in this tabular column. So, 0 is given. So, 0 is rounded here and 5 is given, 5 is rounded, 6 given and then 8, 12, 14, 15. So, by adding each column, we are going to get the value for the multiplexer 8:1 max. So, here both are circled, which means a bar plus a. So, a bar plus a equal to 1. So, we are getting the first input as 1. Here nothing is marked, which means it is going to be 0, second also 0, third also 0. In the fourth one, we are having the value a and fifth we are having the value a bar. Here both are marked, so it is 1 and here it is a. So, it is going to represent the input 0, input 1, input 2, input 3, input 4, input 5, input 6, input 7 for the 8:1 mux. So, we are going to implement 8:1 mux. So, we have 3 select lines, they are B, C, D and we are having one output Y. So, 8 inputs are first input is 1. So, which means it is represented by plus VCC. So, we are giving plus VCC to the first one and 2, 3, 4 are grounded since it has a 0 value. So, 2, 3 and 4. So, they are going to be grounded and the next input we are having A. So, which means I am going to give the A as input for 4 and similarly that is B A bar for the next one and 1 for the sixth input. So, we are giving 1 and for it is going to be A. By this we can implement 8:1 mux for the given Boolean functions. Now, again 8:1 mux is also not a cheapest one. So, for that we are going for 4:1 mux. Here we are going to have implement them using 4:1 mux means let us have the probable input combinations. We have 16 probable input combinations. So, 0 0 0 0 0 1. So, starting from this you have the value up to 1 1 1. Here I am going to group this one with each by 4 terms. So, here it is going to be first quadrant and this is going to be second one and this is going to be third one and this is the final one. So, for 4:1 mux I need 4 input values. So, I am going to collect the 4 input values from these quadrants. For this I need 2 select lines. So, here I have separated this one based on the values. So, if you consider first quadrant AB is always going to be 0 0 0 0. In the second quadrant AB is always going to remain 0 1 and third column it is always going to be remain 1 0 and fourth column it is always going to be 1 1 1, which means these quadrants are classified based on the input AB. So, AB is going to act as a selector line. So, then CD is going to act as the data lines or input line. So, how to select this data value? So, for that I have to take what are the values given. So, 0 is given. So, 0 I am going to take here and 5. So, 0 1 2 3 4 5. So, 5 is given. So, 5 I have taken and 8 is given. So, 8 is present in the third quadrant 8. 12 is given. So, 12 in the third one 14 15. So, I have take all the given Boolean function in the quadrant values. Now, here the only one take is here. So, for that what is the expression? It is going to be C dash D dash, which means the first input for the 4:1 mux is C dash D dash. Similarly, here also the only one variable is selected. So, the expression is going to be C dash D. Similarly, here also it is C dash D dash. And finally, for the fourth column we have 3 elements ticked. So, we have to write the expression for all the 3, C dash D dash plus C D dash plus C D. So, we are going to simplify this using Boolean expressions. So, D bar is common. So, which means it is given by D bar C bar plus C plus C D. Again it is going to be D bar, this value remains 1. So, D bar plus C D. This is again classified by using the Boolean expression or any distributive law. So, this is can be written as D bar plus C, which means the 4 input line or data line for the 4:1 mux are C bar D bar is the first input, C bar D is the second input, C bar D bar is the third input, and D bar plus C is the fourth input. So, based on this data line and the selector line, we are going to implement the given Boolean function using 4:1 mux. So, how to draw the circuit means, so A, B, they are going to be the selector lines and Y is my final output. Here I need 2 input lines. So, C, D. So, 0, 1, 2, 3, 4. So, they are going to be input. For the first one it is C bar D bar. So, I am connecting C bar D bar with the AND gate, and for the second one it is C bar D. So, I am connecting C bar D, and again for the third it is 0th input again. So, I am connecting 0th input here, and for the final one it is D bar C. So, I am getting D bar and C as the final input. So, we can implement the given Boolean function using 16:1 mux, 8:1 mux and 4:1 mux. The difference lies in the selector lines as well as the input we are applying for each one. The cost wise concern means 4:1 mux is better when compared with the 16:1 mux, but component wise concern means 16:1 mux is better because it does not require any additional gates or any other components to implement the 16:1 mux. So, this is the conclusions. So, we can implement any given Boolean function using the multiplexer 1. Thank you.